Hello everyone, in this session we are going to discuss what is linear differential equation and how to reduce the given equation into linear differential equation form. Means today concept is linear differential equation and reduce the given equation into linear differential equation form. First we discuss definition of linear differential equation. Definition is a differential equation is said to be linear if the dependent variable and its derivative occurs first degree only, occurs in the first degree and they are not multiplied together. This is the definition of linear differential equation. Means a differential equation is said to be a linear if the dependent variable and its derivative occurs in the first degree and they are not multiplied together. For an example, first one, derivative of dy by dx plus 9 into y is equal to cos x. This is the first example. Second one, d square y divided by dx square plus dy by dx is equal to sin x. In the last one, d square y divided by dx square plus y into dy by dx is equal to 0. In these three examples, first and second one is linear differential equation. Last one is non-linear differential equation. Linear equation, this is also linear. Last one is non-linear differential equation. It is not a linear differential equation because dependent variable and their derivative both are multiplied together. Linear differential equation means an equation is said to be a linear if the dependent variable and its derivative occurs in the first degree and they are not multiplied together. Okay. Now I am going to explain standard form of linear equation. So standard form of linear differential equation and its solution. So standard form of linear equation means a differential equation is in the form dy by dx plus p into y is equal to q, where p and q are functions of x is called a linear differential equation. This is the standard form of linear differential equation. A differential equation is in the form dy by dx plus p into y is equal to q. Here p and q both are functions of x. It is called linear differential equation in y. Further continuation, we find out the solution of this linear equation. Solution of linear equation is given by y into e power integral of p into dx is equal to integral of q into e power integral of p into dx with respect to x plus c. This is the solution of linear differential equation. y dependent variable into e power, this is integrating factor for the linear equation, e power integral of p into dx, which is equal to integral of q into e power, or integrating factor, integrate the term with respect to x, plus c is an integral constant. This is the solution of linear differential equation. Now I am going to solve the problem in linear equation. First one question is, solve dy by dx plus y into cot x is equal to cos x. This is the first one problem in linear differential equation. So problem is, solve dy by dx plus y into cot x is equal to cos x. In this problem we find out the dependent variable value, means find out the value of y. So first write on the given equation. Given equation means dy by dx plus y into cot x is equal to cos x. This equation is in the form dy by dx plus p into y is equal to q. Just comparing the given equation with standard form of linear equation. For further continuation, just comparing the given equation with the standard form of linear equation. Therefore, p equal to, after comparison p equals cot x and q equals cos x. So p equals cot x and q is equal to cos x. Before writing the solution of linear equation, first find out the integrating factor. So integrating factor for this linear equation is e power, integrating factor equals e power integral of p into dx. So e power integral of p into dx is an integrating factor for the linear equation. Therefore, e power integral of p into dx is same as e power, p is nothing but cot x with respect to x is same as e power. We know that integration of cot x. So integration of cot x is log of sin x. So log of sin x. Here I am using the properties of logarithmic function. Already we know that e power log x is nothing but x. So using this property, e power log x is nothing but x. Therefore applying the same property for this step is equal to sin x. Therefore sin x is an integrating factor for the given linear equation. For further continuation, write on the solution. Solution of linear equation is, so y into dependent variable into e power integral of p into dx is equal to q into integral of e power p into dx with respect to x, plus for further continuation y into, we know that e power integral of p into dx is equal to sin x is equal to integral of q is nothing but cos x, q is equal to cos x into sin x with respect to x plus c, or is same as integral of sin x into cos x with respect to x plus c is equal to y into sin x. For further continuation, integration of this term sin x into cos x. So direct integration is very difficult to find out the integral value. Therefore, for our convenience, we in this equation multiply and divided by 2. 1 by 2 times of integral. We know that 2 sin theta into cos theta is nothing but sin 2 theta. Here 2 sin x into cos x is nothing but sin 2x with respect to x plus c, or is same as 1 by 2 times of integral of sin 2x. Integration of sin is nothing but minus cos theta. Therefore, integration of sin 2x is equal to minus cos 2x divided by 2 plus c. This is integral value of sin 2x. So minus cos 2x divided by 2. Finally, y into sin x is equal to minus cos 2x divided by 4 plus c. This is the required solution for the given linear differential equation. Okay. Now we are going to discuss how to reduce the given equation into linear equation form. Is nothing but Bernoullis differential equation. The next concept is equation reducible to linear form or Bernoullis equation. Equation reducible to linear form or is same as Bernoullis equation. Is same as Bernoullis equation. So, definition of this Bernoullis equation is a differential equation is in the form dy by dx plus p into y is equal to q into y power n, where p and q are functions of x is called Bernoullis equation in y. This is the definition of Bernoullis differential equation in y, means a differential equation is in the form dy by dx plus p into y is equal to q into y power n. Here also p and q both are functions of x is called Bernoullis differential equation in y. Similarly, dx by dy plus p into x is equal to q into x power n is called Bernoullis equation in x. This is Bernoullis differential equation in x. Here also p and q both are functions of x. Okay. Now I am going to solve the problems in Bernoullis differential equation, means we reduce the given equation into linear equation form. The first problem is solve tan y into dy by dx plus tan x is equal to cos y into cos square x. So, first write on the given equation in solution. Given equation is tan y into dy by dx plus tan x is equal to cos y into cos square x. In the next step, whole equation divided by cos y. In this step, whole equation divided by cos y we get. So, whole equation divided by cos y, therefore, tan y divided by cos y into dy by dx. For time being, it denoted by equation 1. The equation 1 divided by cos y we get. So, tan y divided by cos y into dy by dx plus tan x divided by cos y is equal to cos y get cancel, remaining value cos square x. We know that 1 by cos x is equal to secant x. Therefore, here 1 by cos y is equal to secant y. So, secant y into tan y into dy by dx plus similarly for second term 1 by cos y secant y into tan x is equal to cos square x. After dividing, the equation becomes secant y into tan y dy by dx plus secant y into tan x equals cos square x. In the next line, put secant y is equal to t. Then differentiate the term with respect to x. So, differentiate with respect to x. Therefore, differentiation of secant y with respect to x, secant y into tan y. Differentiation of secant is nothing but secant into tan. Derivative of y with respect to x is nothing but dy by dx is equal to dt by dx. This is the derivative of t with respect to x. Using this value and secant y is equal to t in the equation 2. This is equation 2. In equation 2, replace secant y and secant y into tan y into dy by dx. Therefore, equation 2 becomes in place of secant y into tan y into dy by dx is equal to dt by dx. So dt by dx plus, just I am replacing the secant y tan y dy by dx value is equal to dt by dx. In the next step, plus secant y is equal to t into tan x, is equal to cos square x. So this equation is in the form dt by dx plus p into t is equal to q. This is standard form of linear differential equation in terms of t, dependent variable t and independent variable is x. Therefore, the above equation is in the form dt by dx plus p into t is equal to q. Just comparison. So after comparison, here t coefficient is p, therefore t coefficient is tan x, therefore p is equal to tan x and q is equal to cos square x. So integrating factor is equal to integral of p into dx. So e power integral of p into dx is an integrating factor, therefore e power integral of tan x with respect to x. So e power integral of tan x with respect to x. Integration of tan x is nothing but log of secant x. So is equal to e power log of secant x. Again here I am going to use logarithmic property. E power log x is nothing but x. Therefore secant x is an integrating factor. So e power integral of p into dx is equal to secant x is an integrating factor for the given function. Using integrating factor, write down the solution. So solution of given linear equation, the solution is t into integral of p into dx is equal to integral of q into integral of p into dx with respect to x plus c. This is the solution of linear differential equation. Here dependent variable t, therefore t into integrating factor is equal to integral of q into integrating factor with respect to x plus c. Therefore replace back, t is equal to, already we chosen t equals secant y, therefore replace back t value. So therefore t is equal to secant y into integrating factor value secant x. Second one is equal to q is nothing but cos square x, into integrating factor is equal to secant x with respect to x plus c, or is same as for the integration of cos square into secant is nothing but in LHS secant y into secant x is equal to, so cos square x into secant is nothing but 1 by cos, so cos x with respect to x plus c. Here one cos get cancelled, remaining is secant y into secant x is equal to integral of cos x, but we know that integration of cos is nothing but sin x, therefore sin x plus c. This is the required solution. So secant y into secant x is equal to sin x plus c is the required solution of the given problem. Now I am going to solve the second problem in equation reducible to linear form, means nothing but Bernoullis differential equation. So here the problem is dy by dx plus x into sin 2y is equal to x cube cos square y. First write down the given equation as it is. So given equation is dy by dx plus x into sin 2y is equal to x cube into cos square y. So first reduce the given equation into linear equation form and then write down the solution of linear equation. So here whole equation divided by, so in the equation whole equation divided by cos square y, because x cube coefficient is cos square y, therefore whole equation divided by cos square y is same as 1 by cos square y into dy by dx after dividing plus x into sin 2y is nothing but, already we know that sin 2 theta formula 2 sin theta into cos theta, in place of theta here y, therefore sin 2y is nothing but 2 sin y into cos y, 2 times of sin y into cos y, divided by whole equation divided by cos square y is equal to x cube. Cos square get cancel. So R is same as 1 by cos square. Already we know that 1 by cos is equal to secant. Therefore secant square y into dy by dx plus here 1 cos get cancel. Remaining is x 2 times of x into sin by cos is nothing but tan is equal to x power 3. Therefore in the next step put tan y is equal to t. X coefficient is tan y, or 2 tan y is equal to t, or tan y is equal to t. Better just choose the y term. Tan y is equal to t. Therefore differentiate with respect to x. So derivative of tan y with respect to x is nothing but tan y differentiation secant square y. So secant square y into derivative of y with respect to x is dy by dx is equal to t differentiation dt by dx. This is equation 1. In the next step, just replace the dt by dx or secant square y divided by secant square y into dy by dx value and tan y value. So equation 1 becomes, after replacing, equation 1 becomes, in place of secant square y into dy by dx is equal to dt by dx. Just I am replacing secant square y into dy by dx is equal to dt by dx 2x into t, because tan y is equal to t. We are choosing tan y is equal to t is equal to x cube is equal to x cube. Therefore this equation is in the form dt by dx plus p into t is equal to q. The comparison of given equation with standard form of linear equation, we get p equals, so p equals t coefficient, here p equals 2x and q equals x cube. This is p and q. Now find out the an integrating factor for the function. Integrating factor is equal to, so integrating factor is equal to e power integral of p into dx is nothing but e power p is nothing but 2x with respect to x, or is same as e power 2 into integral of x into dx, e power 2 into integration of x is nothing but x square by 2. Here 2 get cancel. Finally integrating factor for this problem e power x square. This is an integrating factor. Further using integrating factor value, find out the solution of linear equation. The solution of linear equation is t into e power integral of p into dx is equal to q into integral of p into dx with respect to x plus c. C is an integral constant. Therefore replace back. So t value, replace back t is equal to tan y. So tan y into integrating factor, already we find out that value. So e power x square is equal to q is equal to x power 3 into integrating factor e power x square with respect to x plus c. Integration of this term by using substitutions method. Therefore put x square is equal to t. For RHS integral of the term by using the method of substitutions, put x square is equal to t, differentiate the term with respect to x. Therefore 2x into dx is equal to dt, or is same as x into dx is equal to dt by 2. X into dx value dt by 2, x cube into dx is same as, so x cube into dx is same as x square into x into dx, just splitting the power, or x square, but we know that x square is equal to t into x into dx, x into dx is nothing but dt by 2. Finally x cube into dx is equal to t into dt by 2. This is x cube into dx value. So x square is equal to t, x into dx value dt by 2, and x cube into dx is equal to t into dt by 2. For further continuation, the solution becomes tan y into e power minus x square integral of, here x cube into dx, x cube into dx is nothing but t into dt by 2. So t into dt by 2. In the next line, e power x square. E power x square is nothing but e power t with respect to t plus c. So after replacing the x square and x cube into dx value, therefore integral becomes t into e power t into dt divided by 2 plus c. C is an integral constant, or is same as, so 1 by 2 taken outside because constant taken outside of the integral. Remaining thing is t into e power t with respect to t plus c. So now integrate the term t into e power t with respect to t by using integration by parts or Bernoullis rule of integration by parts. Here I am going to integrate this function by applying the Bernoullis rule of integration by parts. Therefore 1 by 2 times of, write down first term as it is t. So integrate e power t integration e power t minus alternative sign differentiation of t 1. So mentioning here 1, and again integration of e power t is nothing but e power t plus, for further continuation, differentiation of 1 0, whole term becomes 0 plus c, or tan y into e power x square is equal to, so 1 by 2 times of t into e power t minus e power t plus c. Replace back t equals value, but we know that replace t value, t equals x square. Therefore tan y into e power x square is equal to 1 by 2 times of x square into e power x square minus e power x square plus c. This is the solution of given differential equation. Now I am going to solve the last problem in Bernoullis differential equation. The problem is solve dy by dx plus y by x is equal to y square into x. So first write on the given equation as it is, dy by dx plus y by x is equal to y square into x. In the next line, the whole equation divided by y square. So whole into above equation becomes dy by dx plus 1 by x into y, 1y get cancelled, is equal to x. This equation is denoted by, call it as equation 1. In the next line, put 1 by y is equal to t. The coefficient of 1 by x is 1 by y, put the term, particular term is equal to t. Therefore, my differentiate the term, differentiate this one, differentiate with respect to x. Differentiation of 1 by y with respect to x is minus 1 by y square into dy by dx is equal to dt by dx with respect to x, or is same as 1 by y square into dy by dx is equal to minus dt by dx. So using this value and t value in equation 1, therefore equation 1 becomes 1 by y square into dy by dx is nothing but minus dt by dx plus 1 by x into t is equal to x. This equation not in the form of linear equation, therefore whole equation multiplied by negative sign, whole equation multiplied by minus 1, it becomes dt by dx minus t by x is equal to minus x. This equation is in the form dt by dx plus p into t is equal to q. Just comparison the given equation with the standard form of linear equation, we get p is equal to minus 1 by x and q is equal to minus x, p value and q value. Using p, find out an integrating factor. The integrating factor equals e power integral of p into dx, e power integral of p value minus 1 by x with respect to x is equal to e power minus 1 by x integration is log x. E power minus log x is same as e power log x power minus 1 function. E power log x power minus 1 is nothing but x power minus 1 is equal to 1 by x. 1 by x is an integrating factor for the given problem. Therefore, using an integrating factor, find out the solution. So, solution of linear equation is t into e integrating factor is equal to q into integrating factor with respect to x plus c. Therefore, replace back t. t is equal to 1 by y. So 1 by y into integrating factor is equal to 1 by x is equal to q is nothing but minus x into integrating factor 1 by x with respect to x plus c, x's get cancelled. Finally 1 by x into y equal integral of 1 with respect to x is x minus x plus c. This is the required solution. Thank you.